Hey guys, we got quite the bear for you today. We're going to jump into the difference quotient, and it's a little intimidating at first glance, but before too long, I think you're going to feel pretty good about it, I hope. So we're going to see two things in this video. The first thing you're going to see us do a lot of is we're going to kind of warm up each question after they give us this function. We're just going to practice evaluating f of x plus h, and that's going to kind of be our little warm-up exercise. And then we're going to put it all together and evaluate this entire thing called the difference quotient. Like I said, it can look a little intimidating, but after a couple reps under your belt, I think you're going to be in pretty good shape. So just to kind of set the stage, we've got, we're saying there's a major topic going forward, into pre-calc, into calc and beyond, where we're studying average rate of change. And eventually that gives birth to something really, really special called instantaneous rate of change. And so we're going to look at a ratio today called the difference quotient that plays a really important role in us understanding the rate at which these functions change. Because what we're basically going to get at is when you picture this function right here, every single point on the curve has its own unique rate of change. And so we're going to really dial into that shortly down the road. So here's our definition of the difference quotient. And today I want to kind of stay on the mechanical side and just practice, using our algebra skills to evaluate and simplify this expression. And then down the road, we'll get more theoretical and kind of talk about, where exactly this crazy function and did the thing called the difference quotient kind of comes from. We'll kind of get into defining who is h. For today, we're just going to treat h as another variable. It could be like a y for all we care. So we're just going to practice kind of manipulating this and using our algebra skills. So what's this going to look like here on this first example? Let's see if I can open this up a little bit. All right. So basically, when we say evaluate f of the quantity x plus h, we're basically asking, say, listen, there's an x right here and there's an x right here. Let's replace each of those x's with the quantity x plus h. So this is what it's going to look like. Let's say f of x plus h equals 3. Make your substitution. Minus 2, make your substitution. Plus 5. Doesn't that look crazy? This looks insane. So anyway, we're going to go ahead and we're just going to rewrite the x plus h twice because of the squared sign. You can go ahead and distribute that too if you want, or you could do it in the next move. And then we're going to go ahead and, again, think of your order of operations. I like to just go ahead and FOIL these two together first. So I just carry down my 3, x times x. Then we'll say x times h times x plus h times h. Boy, I'm going to run out of room here maybe. But anyway, now I can start to distribute that 3. Now, one thing I'm going to do here is I'm going to say, okay, if I combine those two terms right here, it's going to give me 2xh. Then when I distribute the 3, that's going to make 6xh. Just kind of saves us a step right there. And believe it or not, that's kind of my so-called answer because there's no terms to combine. So that's what f of x plus h is equal to. Now, really, we did that to make this next step a little bit more manageable. And so we're going to try to evaluate the entire difference quotient right now. And we'll try to color code this a little bit. So this part of the difference quotient is what you just found. So I'm going to go ahead and kind of rewrite that part. So we've got 3x squared plus 6xh plus 3h squared. If we hadn't have done this part already, it's just that much more hectic and confusing. All right, now we're going to switch colors here. Now we have to subtract f of x. What do you mean subtract f of x? Okay, so we've got minus, and then in parentheses, f of x was that original function up here, the 3x squared minus 2x plus 5. Okay, and then that entire thing's got to be divided by h. So let's put this whole thing over h. All right, so just a real quick recap here. So everything in purple is the f of x plus h function, minus, and then everything in pink is the f of x. And now we just kind of got to distribute this little negative sign here and start to combine like terms. So what you're going to see, I might as well just write this out. I don't want to jump the gun here. So we got 3x squared plus 6xh. Boom, 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 boom. Yeah, this is going to take up some room in the old notebook today, huh? All right, so what kind of terms could we combine here? Well, this 3x squared and negative 3x squared are going to cancel. You got negative 2x with positive 2x and a positive 5 with a negative 5. So now I just kind of want to highlight who's still actually alive because it feels like I canceled more terms than not. You've still got these two terms and this term right here are still alive. So let's rewrite it. So 6xh plus 3h squared minus 2h all over h. Now to simplify this, I'm going to factor out a GCF of h onto that numerator. So let's see, this term becomes 6x, this term becomes 3h, and this term becomes minus 2. Now we can cancel, and today our final answer is 6x plus 3h minus 2, and that's where we stop today, okay? That's where we're going to stop. Our second example is going to be almost the same thing, except I got this little bear trap with a negative leading coefficient. So other than that, I don't think there's anything that should be scary here. So just a real quick recap, we're saying these x's right here are going to get replaced with the quantity x plus h. So I'm going to go ahead and make that substitution. And I'm going to say f of x plus h equals negative 2. Make my substitution. Plus 6, make our substitution, okay? And then we're off to the races. It's just a lot of like good old-fashioned hardcore algebra. I'm going to distribute my 6. And as you get better and better at these, you're going to be able to skip some of these steps, but we're not in a hurry to skip any of them, until you're comfortable and ready to do so. We're not going to push that factor. Notice and again, you're going to get really good at foiling this expression right here. You're going to, that's going to be as natural as tying your shoe. I'm going to distribute that negative 2. So I get negative 4xh in the middle here minus 2h squared plus 6x plus 6h. And it feels like I should be able to do more, but that's actually, I've exhausted all of my options because I don't have any like terms to combine. So we're going to consider that our answer. And really that's going to feed into this next question here. So let's see what we got cooking. So first thing I'm going to do is, let's keep the colors consistent here. I'm going to basically import my previous answer. So we already found f of x plus h. I'm just going to rewrite my answer from the last problem. Make sure I can see that here. So we got negative 2x squared minus 4xh. A big part of today is just being able to stay organized, trust the process, and not overly rush things. Now, I've got minus f of x. And a lot of times, I'll tell you what, whoops, I'm going to change my color. So we got the minus. Let's see, what was that original function? Was it negative 2x squared plus 6x minus 1? If I don't put these parentheses in there, that's going to screw things up for me. So I got to really be disciplined with those parentheses. And what you're going to see us do now is let's go ahead and distribute that negative. And then eventually we can start to combine some like terms. And if you're starting to feel confident, don't be afraid to work ahead of me here. I bet you're starting to feel. So that's going to be positive 2x squared minus 6x positive 1 once I distribute. Now, who can you cancel here, huh? Who can we cancel? Let's say I got a negative 2x squared cancels with a positive 2x squared. I got a positive 6x cancels with the negative 6x. Negative 1 cancels with the positive 1. If all those bears canceled, who the heck's still alive? I've got negative 4xh minus 2h squared plus 6h. So I'm going to rewrite those bears. Negative 4xh minus 2h squared plus 6h all over h. All right, let's take out a GCF of h. So I'm left with negative 4x minus 2h plus 6. Whoops, forgot my parenthesis. Cancel those h's, and now we have what we consider our most simplified answer. Okay, Now, what I want to, so I want to, if you're, depending on how you're feeling, if you're feeling 60% confident, 40%, 80%, wherever your confidence level is right now, I want to give you one more opportunity to take that confidence up a notch by trying this one last example. Let's hit the pause button together. Let's go try it, and then we'll come back and compare work. Good luck. So here's what my f of x plus h looks like after I made the appropriate substitutions. I think maybe the biggest bear trap is just keeping this negative on the outside. Go ahead foiling that x plus h with the negative still on the outside. And then when the time is right, we're going to distribute that negative to get these signs right here. And that's the best I can do. Let's take a look. Let's do the same thing here. Let's give it our best attempt on cleaning up the difference quotient here and simplifying it as much as we can. And we'll do the same thing. We'll come back and compare note. All right, so here's my difference quotient. A couple of things I want to emphasize here. Hopefully we've got parentheses around our f of x function so that we get that negative distributed. Then we were able to cancel these x squareds. We were able to cancel the 3x and cancel the 10. We rewrote what was still alive. And we factored out this GCF of h, which allowed us to cancel that and simplify the expression. And so we're thinking negative 2x minus h minus 3 is our final answer. All right. Thanks for hanging in there. These were no small bears today. And keep chugging along. And before you know it, you're going to be a rock star at these. All right. Have a good one, guys.